Math lesson 4. This is on pressure in PSI. PSI stands for pounds per square inch. Question number 1. A column of water is 670 feet high. What is the pressure in PSI at the bottom of the column? Now I want to note something of importance here. Let's say I have a column. Call it a ground storage tank. If this is 40 feet in height, and 40 feet in diameter, the pressure at the bottom is going to be 17.32 psi. Now let's say I have a pipe. And let's say this thing is 10 feet in diameter, but 40 feet in height. 40 feet times the conversion factor is 17.32 psi. It doesn't matter if it's a lake or a large ground storage tank or a column. It doesn't matter how much water is in that reservoir, in that tank or basin. What matters is the depth. Okay, now that we have that straight, let's figure out how to determine this, how to make these calculations. If we go to our ABC math formula sheet, we can see that 1 foot of water is equal to 0.433 psi, just under half. So if I have 10 feet of water, I know that the pressure is going to be less than 5 psi. In fact, it's going to be 4.33 psi. How do I know that? Well, let's also note that 1 psi is equal to 2.31 feet of water. Now, this is one of those times when I can take this conversion factor, 0.433, or I can use this 2.31 feet of water per psi. I could use one or the other to make these calculations. I've chose to stick with one, the 0.433 psi per foot of water. By doing that, I feel like it's less complicated. So let's put this in the form of an equation. I want to know what is the pressure in psi at the bottom of the column. That's what the question is asking me for. Remember, you always, whenever you're taking your certification exams, when you're studying for these things, when you're in the lab making calculations, what do you need to know? What is the unit of measure you're looking for as your conclusion? So I want pressure in psi. So we're going to write psi equals, now we know that there is, for every foot of water, it equals 0.433 psi. So let's take our 675 feet and multiply that by 0.433 psi per foot. .675 times 0.433, and that's going to give us 292.28 psi. Well, how do I know I did it right? I'm looking for psi. I have 675 feet, and then I have 0.433 psi per foot. If I take this foot right here and put a division line with a 1 underneath, it means the same thing. But what that does for me is it gives me that division line here. There's a division line here. I can cancel out this foot and this foot. I'm left with psi, which is what we're looking for. The correct answer is B. Except that, look at that. Look at that unit of measure. If I would have kept it that way, it would have been wrong. The answer is A, 292 psi. Math has always been a struggle for me throughout my life. I'm 54 years old at the time I'm making this video. And what has helped me, to be quite honest, is training operators. I've trained dozens and dozens and dozens of operators. I've helped them get certified from grade 1 to grade 4. And in Arizona, grade 4 is the highest certification you can receive in any discipline. And part of training those operators is doing the math, doing it over and over and over again. So even with that level of redundancy, there are times when I'll make a mistake. I'm going to leave this here so when you watch the video, you can see it's okay. Just take a look at your work. See if it makes sense. As soon as I answered B and I saw the unit of measure, I realized I had made a mistake. I needed psi, which is a really good reason why we go through this process of cross-canceling to get down to the unit of measure that we're looking for, which was, in this case, the pressure in psi. Okay, question number 2. A cylindrical tank is 45 feet high and full of water. What is the pressure in psi at the bottom of the tank? We want to calculate pressure in psi. So we'll start with the formula. psi equals, we're going to call this height, multiplied by 0.433 psi per foot. So let's write that out and let's get the height in this formula. The height is 45 feet high, and this question was very specific. It's 45 feet high and full of water. So we know we're going to get from the water surface all the way to the bottom. The weight of the water is pushing down on the bottom of that tank. The height, 45 feet over 1 multiplied by 0.433 psi per foot. Let's cross cancel. We have a division line here, right, and a dividing line here. We have a foot above, 1 foot below, We'll cross cancel those out. We're left with PSI, which is what we're looking for. Now it's down to the math. 45 times 0.433, and that equals 19.485. We'll round the 8 up to a 9. PSI. 19.49 can be rounded up to 19.5. Typically, it would be like 19.5. Yep, there it is. There's a 9.5. Correct answer is D. Question number 3. What is the pressure and PSI at the bottom of a tank 45 feet in diameter, 25 feet in height, with a water depth of 13 feet? Pressure and PSI is what we're looking for. Now we know our formula. If we want the pressure in PSI, we'll take the height, multiply that by 0.433 PSI per foot. Now very quickly, I want to explain one thing. If this is the first video of mine that you're watching, whenever I have a decimal point and there's nothing before the decimal point, I always write a 0. As an operator, we want to be very, very specific in our record keeping. It's state and federal law, at least here in Arizona, that we maintain clear, legible, accurate records. If we leave that 0 off, that decimal might be missed by somebody who's looking over our work. I just find it, and I train my operators to do the same thing, the students in my program. Write that 0 down before the decimal. Takes out any question or doubt. So this is the formula we're going to use. PSI equals the height multiplied by 0.433 PSI per foot. Let's rewrite this formula and stick in the height. The height. Now keep in mind, it doesn't matter that the tank is 45 feet in diameter. Doesn't matter how wide it is. The only thing that matters is the depth of the water. So with the tank being 25 feet in height, that doesn't mean anything either. What we're concerned about is the water depth, which is 13 feet. So we're going to write 13 feet over 1. 13 feet and 13 feet over 1 is the same thing. What that's going to allow us to do is cross cancel. 0.433 PSI per foot. Now let's cross cancel and make sure that what our answer is going to be in PSI. I have a dividing line here, a dividing line here. There's a foot over, a foot under. I'll cross cancel those out. I'm left with PSI, and that's what we're looking for. So now it's time to do the math. (13) times 0.433 equals 5.629. We'll call it 5.63 PSI. And look at this. The best answer is 5.6 B. Question number 4. A pressure gauge at the bottom of a storage tank reads 50 PSI. What is the water level in the tank in feet? What is the water level in feet? We'll call that depth. And they want it in feet. Water level, feet. Okay, so we'll need a formula to figure this out. Now we know that for every foot of water, it equals 0.433 psi per foot. That's in our ABC math formula sheet. You can go to my website. The link is below the video. You'll find a link that will take you to the ABC website where you can download these math formula sheets for free. There's one for water, water treatment and distribution. There's one for wastewater treatment and collection. You want to select the 2017 US-Canada math formula sheet. All right, let's write down this equation. So we want depth is equal to the PSI divided by 0.433 psi per foot. That's our formula. And we can write this formula because we know this. For every foot of water is 0.433 psi per foot, right? Let's write this formula down and we'll stick in this information from the question. Depth equals, now what's the pressure? The pressure is 50 psi. So this is a pressure gauge at the bottom of a ground storage tank. So we will put in 50 psi over 1. We'll divide that by 0.433 psi per foot. Now let's cross cancel. We have a dividing line here. We have psi over this dividing line. We have psi over this dividing line. They cross cancel each other out. We're left with feet. And this depth will be in feet, which is what the question wants us to do. 50 divided by 0.433, and that's going to give us 115.47 feet. Had to double check my unit of measure. It's the same, 115.47. We can round that up to 115.5 feet. The answer is G. Question number 5. A pressure gauge at the bottom of the standpipe reads 83 psi. What is the water level in the pipe in feet? This is a hell of a standpipe. Water level in feet. We're going to call this depth in feet. That's what we're looking for. Our formula is going to be the depth in feet is equal to PSI divided by 0.4333. That's in my head now. 0.433 PSI per foot. Let's rewrite the formula. We'll get the conversion factor correct this time. Depth in feet equals, pressure gauge at the bottom of the standpipe reads 83 psi. 83 psi over 1, 0.433 psi per foot. I'm just being a little extra careful. Please keep in mind, I've said it in previous videos, I'm 54 years old and I've struggled with math all my life. Cut me a break. So let's cross cancel. We have 83 psi over 1, 0.433 psi over foot. We have a division line here, division line there, division line there. Psi over psi. We can cross cancel these out. We're left with feet, and feet is what we're looking for. 83 divided by 0.433, that gives us 191.6. We're going to round that up to 9 feet. The best answer is 192 feet. A. Question number 6. The pressure measured at the pump discharge for a reservoir reads 130 psi. What is the depth of the water? We want to know what the depth is. So let's write out our formula. We want to know depth equals psi divided by 0.433 psi per foot. Now we'll rewrite this formula sticking in that 130 psi. We're solving depth. In feet equals 130 psi over 1. Divide that by 0.433 psi per foot. Let's cross cancel. We have the dividing line. Psi over 1, psi over feet. We'll take out the psi. We're left with feet. That's the unit of measure we want. Let's do the math. 130 divided by 0.433, that gives us 300.23. That was my work phone, even though it's Sunday. I still get phone calls. I run field operations for a water wastewater utility. That's everything from the well site to the customer, from the customer to the wastewater treatment plant. So the distribution system, the collection system, and everything involved in both those systems. I have 33 lift stations, soon to be 34. There's a couple more planned, so I have a rather large system. We move a lot of water. With that said, we calculated 300.23 feet. The best answer is D. Through the magic of video, I have returned. Got called out. Had to go take care of a couple things, but here I am. I'm back. Question number 7, which is a challenge question. A 1 million gallon a day wastewater treatment plant has 2 aeration basins. We call them ABs. They're in parallel. The ABs are identical in size. 104 feet in length, 46 feet in width. The bottom of each AB is sloped, with the downstream side deeper than the upstream side. The bottom of each basin is 82 feet in length and 36 feet in width. The pressure at the deepest part of the basin is 6.49 psi. So question 7. What is the combined surface area for both ABs? We're looking for area. Now, we have, and I'm going to do what's called a plan view. A plan view, when you have a set of blueprints, is looking from up down. So it's from overhead, like say from a drone. So it sounds like we have two aeration basins in parallel, which means they're side by side. If water enters this side and exits this side, we call this the influent side. And this is the effluent. The influent side is upstream of the process. And again, these are ABs. The effluent is downstream of the ABs. Okay? These are terms that we use quite a bit in the water wastewater industry. Now, it wants to know what is the combined surface area for both ABs. Well, all we need to do is figure out what the surface area is for one of them and multiply by 2. So the ABs are identical in size, 104 feet in length. So in length, they're 104 feet and 46 feet in width. Well, let's make some calculations. We know that from our ABC math formula sheet, area is equal to length multiplied by the width. Excuse me. So let's rewrite this formula with all the best parameters in there. We want our unit measure to be square feet. Area is square footage. We're going to put in the length, which is 104 feet in length. We want the width is 46 feet in width. Now we want the combined surface area for both ABs. Since this is the dimensions for one of them, we're going to multiply that by 2. All right? Let's do the math. 104 times 46 times 2, and that gives us 9,568 square feet. How do I know it's square feet? Well, I have a unit of measure in feet here, another unit of measure in feet here. That's 1, that's 2. We have feet squared. These units of measure match up. The correct answer is B, 9,568 square feet. If you look at your choices, you could have eliminated 2 of them right away. We're looking for area. Area is in square feet. We can remove C, which is in cubic feet, and also D in cubic feet. We knew it was going to be one of these had we looked. All right, we have 3 more questions. Question number 8. What is the depth of each AB on the downstream side? We want the depth on the downstream side. Well, it shows us that the question, or the challenge, tells us that the pressure at the deepest part of the basin is 6.49 psi. Now, if I take a profile view Keep in mind, I just went over the plan view, which is a view from the top, from overhead looking down. If I look at a plan view, and I'll just go ahead and write it. Or, hold on. Plan view is overhead looking down. Profile view is like a cutaway. You're looking at it from the side. So in this case, I'm going to look at it from the profile view, which is going to be like this. This will be the top of the basin. This is the influent side, where the water enters the plant. This is the aeration basin, and the water leaves this way as effluent. This is the upstream of the AB. This is downstream of the AB. All right. Now, it says in this challenge, the bottom of each aeration basin is sloped, with the downstream side deeper than the upstream side. So this is the downstream side, the effluent. This is the influent side. So we know that the bottom of every aeration basin is sloped. It's deeper at this point of the aeration basin. Now, it says that at this point, at the deepest point, it is 6.49 psi. So what is the depth of each AB on the downstream side? This is the depth of the water. So I want to know the depth. To get depth, I'm going to take the PSI and divide it by 0.433 PSI per foot. So let's write out the equation. I have depth, and I need feet. Because I already have PSI, I'm looking for feet, right? Now, look at your four choices. 15 feet, 28 feet, 15 PSI, 28 PSI. Well, I'm looking for the depth in feet, so I'm going to eliminate C and D. That equals 6.49 PSI over 1. We're going to divide that by 0.433 PSI per foot. Now let's cross cancel. We have a dividing line here. We have PSI over a dividing line, PSI over a dividing line. I can cross cancel these out. I'm left with feet, which is the unit of measure we were trying to calculate. 6.49 divided by 0.433, and that's going to give us 14.99. I'm rounding that 8 up to a 9 feet. I would say the best answer is A, 15 feet. Question number 9. If the pressure at the bottom of the upstream side of the basin is 5.2 psi, what is the depth of the water? What are they asking us here? If the pressure at the bottom of the upstream side of the basin is 5.2 psi, what is the depth of the water? All right. So let's go with an equation. It says depth equals PSI divided by 0.433 PSI per foot. So rewrite that equation, plug in this value. So we're going for depth, and we want it in feet, equals upstream side of the basin, 5.2 PSI over 1 divided by 0.433 PSI over foot. Let's cross cancel. We're going to cross cancel this PSI and this PSI. We're left with feet, which is the unit of measure we're looking for. Let's make our calculation. 5.2 divided by 0.433 equals 12. So the depth is 12 feet. The answer is D. The final challenge question, number 10. Before I get going into that, let me just cover this again. If you like what you're seeing here, if it's working for you, please like the video. It helps me as a owner of a YouTube channel. It helps my business. Please subscribe. Watch my other videos. If you're like me, you've struggled with math all your life, it helps to follow this video for many of my students in my lecture series. Please leave a comment. It could be a question, and I'll do my best to answer them. I am responsible for all field operations for a water wastewater utility. We have 33 lift stations. I cover everything from the water plant to the customer, from the customer to the wastewater plant, including lift stations. I'm busy. My days are packed, and I get called out on the weekends and at night, but I will do my best to answer questions and answer comments that are left on my YouTube channel. Follow the link below this video. It goes to my website. It's my second stream of income. It's very affordable. And right now, at the time I'm making this video, there's only going to be the one link, which will have all the PDFs for this video series, all the math questions, and the answer keys. You'll also find links to the ABC website where you can download for free the ABC formula conversion tables. There's one for water treatment and distribution. The other is for wastewater treatment and collection. You want to get the 2017 USA Canada version. It's the latest version. Now let's go on to question number 10. What is the volume in gallons for one aeration basin? It wants volume in gallons. Now, as we've discussed in previous questions, we've used pressure to calculate the depth. The way to get this basin to figure out what the gallons are, we have to figure out the volume in cubic feet. That's the formula we're going to use. That formula is going to be volume equals length multiplied by the width by the height, or depth. And I put that in there because many questions will talk about depth versus height. And I want to use those terms interchangeably. Now, what we have here are aeration basins, and typically they're sloped. As I described in an earlier video, you have the influent side, the effluent side, the AB. Upstream of the AB is the influent, downstream of the AB is the effluent. So we have measurements here for the ABs that are in identical size. It's got a length of 104 feet, a width of 46 feet. We know the second aeration basin, the bottom of the aeration basin is 82 feet in length, 36 feet in width. We know that the pressure at the deepest part of the basin is 6.49 feet, and we use that to calculate the depth to be 15 feet. In the most previous question, we found that the most shallow part of the basin is 12 feet deep. And I'm going to put that right here, 12 feet to 15 feet. Okay. So let's draw this out. Let's see what it looks like. We have a basin. Shallow on one side, deep on the other. So the floor slopes away from the influent side to the effluent side. So how do we get the volume of this basin? Well, we're going to have to look at this as two different basins. We're going to start with the surface area. The surface area of this basin is 104 feet in length. And I'll just write it like this, 104 feet. The width is 46 feet. And we'll do the shallow side first. The shallow side is a height of 12 feet. We're going to do the second basin, or the floor, excuse me. The floor of the basin is smaller. It has a length of 82 feet. It has a width of 36 feet. And it has a depth on the deep side of 15 feet. Call that height, 15 feet. All right, we're going to call this Basin A, Basin B. So we've taken this basin and we've made two separate basins out of it. What we're going to do is we're going to calculate the volume in gallons, just as the question asked us to do, for this basin and then this basin. We'll add those together, divide by 2. That's going to give us an average, which will hopefully be one of our answers. So using this formula, we're going to go volume in gallons. We're going to go for A equals length, which is 104 feet. And we're going to put 104 feet over 1. do width. Which is 46 feet over 1. We're going to go with the height, which is 12 feet over 1. And we're going to use our conversion, 7.48 gallons per cubic foot. For every cubic foot of volume, there are 7.48 gallons of volume. I'm going to add that right here, 7.48 gallon per cubic foot. If you want more information on that, go to my previous videos. Now, let's cross cancel. We have foot once, twice, 3 times. That eliminates the cubic feet. Leaves us with gallons, which is the unit of measure we're looking for. So let's solve. 104 times 46 multiplied by 12 times 7.48, and that's going to give us 429,411.84 gallons. Well, you know, that's pretty interesting right there, because look, that 427,818. It's very, very close. Don't be fooled. Let's eliminate that right now, because we know that's not the correct answer. Now let's solve for B. The volume in gallons for B equals the length, which is 82 feet over 1. The width is 36 feet over 1. The height is 15 feet over 1. And the conversion factor is 7.48 gallons per cubic foot. Let's cross cancel. And get rid of this foot, that foot, a third foot, and that's cubic feet. We're left with gallons, the unit of measure we're looking for. And now let's solve. 82 multiplied by 36 multiplied by 15, multiply that by 7.48, and we get, I want to make sure everybody can see this, 331,214.4 gallons. We're not done yet. We are not done yet. So let's take A, 429,411.84 gallons. We're going to add that to B, 331,214.4 gallons. Let's add those together. 429,411.84 plus 331,214.4. That is 760,626.24 gallons. Now the final step to solving this is we will take the 760,626.24 gallons and we will divide that by 2. Divide by 2, and that gives us 313.12 gallons. The correct answer is B. Thanks for following along with me. Like, comment, subscribe, hit the links. Thanks for being here. Look forward to the next video.